The dream of a single superfood or supplement that extends human lifespan is deeply appealing, like discovering the dietary version of the fountain of youth in your kitchen cabinet. But the reality of nutrition is more like trying to find genes that fit everyone. Complicated, often frustrating, and heavily dependent on your unique build. When it comes to nutrients like niacin, what fuels vitality in one person might stoke inflammation or metabolic chaos in another. Personalized nutrition, therefore, isn't a luxury. It's a necessity if we're serious about using diet to extend health span. Niacin, vitamin B3, for instance, plays a central role in energy metabolism, DNA repair, and cellular signaling. It's a precursor to NAD+, the molecular currency of cellular energy, and the darling of the longevity world. But the effects of niacin aren't universally beneficial across all bodies. Some people convert niacin to NAD+ efficiently. Others produce more metabolic byproducts like 2-PY and 4-PY, compounds now suspected of promoting vascular inflammation when chronically elevated. So, while niacin may help one person's mitochondria function like a Swiss watch, in someone else it might just be quietly pouring gasoline on a smoldering fire. Genetics is one of the biggest culprits behind this divergence. Variations in the NADSIN1, NEMPT, and CD38 genes can influence how effectively niacin gets converted to NAD+, how long NAD+ sticks around, and how well it activates sirtuins, those cellular guardians of genome integrity and metabolic balance. People with certain polymorphisms in these genes may need more or less niacin to achieve similar cellular effects, or may benefit more from specific forms, like nicotinamide riboside, NR or NMN, instead of plain old nicotinic acid. Then there's your microbiome. Trillions of bacteria that not only digest your lunch but also participate in B vitamin synthesis and transformation. Some gut species can synthesize niacin on their own, while others metabolize dietary niacin into compounds that may be more or less bioavailable or even harmful. For example, microbial fermentation of tryptophan, a niacin precursor, can yield either beneficial anti-inflammatory metabolites or problematic ones, depending on your gut's composition. A microbiome dominated by certain firmicutes may enhance niacin recycling, while a bacteroids-heavy one might not. This isn't science fiction. It's emerging data that could soon inform how we build diet plans, especially for aging populations. Past and present health conditions also shift the nutritional landscape. Take metabolic syndrome or prediabetes. Individuals with these conditions may have altered niacin metabolism and are more likely to experience niacin-induced insulin resistance. What might be a pro-longevity intervention in a healthy 30-year-old could raise blood sugar and triglycerides in someone with compromised insulin signaling. The same nutrient that activates protective sirtuins in one person could inhibit glucose tolerance in another. It's like giving everyone the same prescription glasses regardless of their eyesight. It won't just be ineffective. It could make things worse. Even seemingly unrelated medications can affect how nutrients behave. Statin users, for example, often have impaired CoQ10 synthesis, a problem niacin doesn't fix and may even exacerbate if it worsens muscle fatigue. Others may be on medications that alter liver enzyme activity, affecting how niacin is metabolized and increasing the risk of toxicity even at modest doses. This is where personalized nutrition steps in, not as a wellness buzzword, but as a rational, science-based approach to aging well. The goal isn't to drown in genetic testing and microbiome sequencing, but to appreciate that variability matters. You wouldn't take a random person's dose of thyroid medication or insulin, so why assume that their vitamin regimen is right for you? The emerging model focuses on clinical biomarkers like hsCRP, fasting insulin LPA, lifestyle patterns, circadian alignment, exercise, sleep, and yes, even digital health tracking to tune nutrient strategies to individual biology. Longevity isn't about megadoses or miracle pills. It's about metabolic harmony, supporting systems that keep the body flexible, adaptive, and efficient as it ages. For some, that might mean moderate niacin intake with early time-restricted feeding and polyphenol-rich meals. For others, it might involve niacin avoidance entirely in favor of boosting NAD+ via fasting, exercise, or other precursors like NMN. There's no one-size-fits-all key to the lock of aging, just a growing understanding that your biology writes the rules. In the end, personalized nutrition doesn't just extend lifespan, it enhances quality of life. It's the difference between aging by default and aging by design. And the first step in that design? Knowing that what's good for the average person may not be good for you.